A single regenerative farm operates as a biological island. Without a backup system, one heat wave or pest outbreak can wipe out the entire season's progress. To survive these environmental shocks, growers must stop acting as individual consumers of fertilizer and start operating a decentralized central bank of biology. This is the Community IMO, or Indigenous Microorganism Bank. It functions as a localized exchange network designed to share and preserve heirloom soil genetics. Banking these local genetics collectively provides the only reliable insurance for a farming community. It ensures that if one cell fails, the network holds the data to restore it. The primary rule of the bank is to never store biology in a liquid state. Liquid cultures are unstable, they consume their fuel quickly and collapse into putrefaction. We create a stable currency called IMO2. This involves taking harvested wild mycelium and mixing it with unrefined brown sugar in an exact 1-to-1 ratio by weight. High osmotic pressure from the sugar extracts the cellular water from the microbes. This dehydration induces a state of suspended animation. It preserves the specific local genetics without killing the organism. The bank also stores a second asset, the melanin-rich biofilm. This is the dark sludge harvested from the bottom of mature purple non-sulfur bacteria, or PNSB, reactors. This stabilization process turns ephemeral, rotting biology into a shelf-stable currency. Once locked in sugar or biofilm, these microbes hold their metabolic voltage for up to 3 years. Every vault needs a banker. This role acts as the uncompromising gatekeeper for every biological deposit the community makes. The banker's main objective is to prevent biodrift. This is the entropic shift where a beneficial fermentation degrades into pathogenic putrefaction. A viable deposit must pass the sensory audit. It should smell distinctly of sweet wine, baking bread, or forest earth. Any jar that smells of vomit, rotten eggs, or sewage fails the audit. These deposits are immediately rejected and destroyed to protect the vault. Strict sensory gatekeeping is the only defense mechanism the network has. It prevents a single bad batch from causing a catastrophic biological collapse across the neighborhood. In temperate zones, winter presents a total biological gap. Beneficial soil microbes either die or go completely dormant during the freeze. To maintain momentum, the network uses the winter bridge protocol. Designated keepers move the liquid mother cultures indoors for the season. These bridge cultures require a constant 25 degrees Celsius. Keepers use seedling heat mats to mimic summer soil temperatures during the freeze. They also provide 18 hours of warm white or infrared LED light. This keeps the photosynthetic machinery of the bacteria active when the sun is too weak to support them. Establishing this indoor bridge prevents the community from losing a full year of genetic adaptation. The microbes stay awake and ready for the spring. The first major payout of the bank is the spring IPO, which occurs every March. By distributing activation batches from the winter bridge, the network gets a biological head start weeks before the soil naturally warms up. The second payout is the rescue protocol. This is used when a community member's personal biological brew fails. Standard rescue attempts usually involve pouring harsh synthetic liquids onto dying soil in a desperate effort to save the crop. Under the IMOB protocol, the grower avoids the pharmacy entirely. They simply withdraw 50 grams of dormant IMO2 from the community bank. This small withdrawal allows the grower to reboot their entire farm's biology for the cost of a single boiled potato. This is risk-adjusted equity. The value of the bank is measured by the retail costs the community avoids when a system crashes. The bank eliminates the need for panic buying, turning a potential disaster into a manageable 50-pence restart. An allotment node functions as a regional generator, culturing the master biology for the entire postcode. Community resilience is built on 3 pillars: stabilizing raw IMO2, maintaining the winter bridge, and serving as a biological backup drive for the network. This shared biological archive acts like a subterranean fungal web, weaving individual farms into an interconnected grid that is far more resistant to external threats. Apart, we perish, but together we ferment. By banking our local biology, we distribute biological sovereignty and ensure the health of our soil remains in the hands of the community.